Jai Hind everyone. I am Shruti Jain, Assistant Professor, MCA Department, Ajay Kumar Garg, Engineering College, Ghaziabad. The topic that I am going to discuss today is blockchain topic, and this topic is covered under the subject Fundamentals of Computer and Emerging Technologies. The subject code is BMC 101 and it is meant for MCA first year students first semester. So first let's understand what blockchain is. So blockchain is a concept which is defined as the chain of blocks that contains the information. So like we have the ledger of whatever transactions we are doing. So it is a kind of a ledger which keeps a track of all the transactions in a transparent manner, and there is no tampering or any editing being done when we are working on the blockchain concept. So blockchain is a constantly growing ledger that keeps a permanent record of all the transactions that have taken place in a secure, chronological and immutable way. It means that it only keeps an add-on to whatever already exists. Whatever transactions we are making or whatever things we are doing into the blockchain, it keeps on adding, and it does not allow us to make the changes into the previous records. So it is a kind of a immutable ledger. The technique is intended to timestamp the digital documents so that it is not possible to backdate them or temper them, as we have just talked about, that it is immutable, we cannot make the changes. So these are the digital documents and they have a timestamp on them. That means once it is being recorded, it is being secured, then we cannot make the changes into these ledgers, or we cannot backdate it, we cannot change the dates or the timings or make the changes into it. The purpose of blockchain is to solve the double spending record problem without the need of the central server. So double spending record problem will look into the future slides. Just for the context over here, that double spending record is where a particular amount is being spent on two different transactions and two different things have been purchased for the single money, where there is no central server to keep a record whether that money is sent to say person A or it is sent to person B or both of them. So blockchain is used for secure transfer of items like money, property, contracts, etc. without requiring a third party intermediary like a bank or a government. So if we are making any of the transactions in our day-to-day life, there we need a central security, central party, that is a bank or government, where we are making the transactions possible. If we are going to suppose buy a land or a property, in that case we need some government interventions or the government officials to have a contract between the two people. But if we are talking about blockchain, then we do not have this third party concept. It is just a transaction between the sender and the receiver. So once the data is recorded inside a blockchain, it is very difficult to change it because it is available over the internet. It is a centralized process. So if you are making a change at one place, then that change has to be confirmed by all the people over the who are using that blockchain, and it becomes a tedious task to make a change. The blockchain is a software protocol like SMTP for emails. So however, blockchains could not be run without the internet. It is also called meta technology as it affects other technologies. It comprises of several pieces, like we have the database, the software application, some connected computers, etc. Obviously, because blockchain is a concept which stays on the cloud, so we need to have the internet in order to make it possible, and it also affects other technologies, and it is comprised of different pieces where we have the database, the software application, some connected computers, etc. So the key points are, the first one, like what all are the components or what all are the main points when we are talking about the blockchain. It is a file that is constantly growing. We cannot reduce it, we cannot delete anything from it, but it keeps on growing and growing, because every other second there is one block which is being added into the ledger. It is permanent. Once the transactions goes inside a blockchain, you can put it up as a permanent value or a permanent transaction in the ledger. So it once recorded, it cannot be deleted. It is secured because the blockchain places the information in a secured way. It uses very advanced cryptography to lock the information inside the blockchain. We cannot make the changes into whatever data we are storing into the that ledger account. It is chronological in order, which means that every transaction happens after the previous one. It is not a simultaneous process that there are two transactions which are happening at the same time and a single person is doing those transactions. So, it is like a sequential order. Once the previous transaction gets over, only then the other transaction will start and it will be executed. It cannot happen simultaneously. It is immutable. It means that as you build all the transactions onto the blockchain, this ledger can never be changed. That means we cannot make a change into the ledger. We cannot edit it, or we cannot delete any of the transaction which is already recorded into the blockchain. So, as we were discussing about the double spending problem, so we have a situation where there are two people, Bob and Lisa. Now, Bob is taking some books in exchange of the money that he had some money, so he gave some money to Lisa and Lisa in return gave him the books. So, if we look over here, Bob is tendering a $10 bill to Lisa in exchange of a book. So, once Lisa receives this physical $10 bill, there is no way for Bob to reuse this money for some other transaction, as a physical currency is now in Lisa's possession. So, this is the concept where we are talking about the physical money, where we have $10 bill and he had that currency and he gave that currency to Lisa, and now Lisa is the owner of that currency and now she can use that currency as and when she needs. But now, if we look into the situation where Bob is making a transaction using the digital coin. Now, when he is making the transaction with the help of digital coin, because there is no involvement of any third party, now digital coin is not available physically with him. So, he can do that, he can make a copy of that digital coin and he can do the transactions, two transactions with the same money. One transaction can be done with Lisa and the other transaction can be done with Alice, because there is no record of this digital coin, how it is spent and how to whom it is being given by Bob. So, this digital coin, because this is a digital money, there is no currency or there is no hard paper with him, he can use this digital coin for transaction with two people as well. But this is a problem because digital money can only be transferred to a single person at one point of time. So, as a format of money exchange is in the digital format, it is essentially a binary physical file which is stored somewhere on Bob's device. Now, once Bob gives this file or the digital money to Lisa, he can also give a copy of this file to Alice, because he can have multiple copies of that binary file and he can use that file for transaction with different people. Now, both will think that they have received the money without having any means of authentication, that the digital coin that they have received and would thus deliver their respective goods to Bob, but they haven't received anything. So, this is called the double spending, where the sender spends the same money at more than one place for obtaining the services or goods from multiple vendors. Now, what is the solution to this double spending? Because this is unethical. You cannot spend the same amount of money with the same money with two different people at the same time. So, for that we had an option to employ a centralized authority to monitor all these transactions. So, in case of the physical money that we have, the centralized authority that we have is like a bank, where you are taking some physical money, having it with you, and then you make the transactions, or you directly give it to the bank. Or we can have a ledger where all the transactions are being recorded, whatever transactions Bob is making with Lisa or Alice. So, the centralized authority, which in common terms could be a bank, they maintain a ledger book recording all the transactions. Now, Bob has to send his digital money to the bank, who would make an entry into his ledger debiting the Bob's account. So, now what the bank is doing in general terms also, suppose A is transferring money to B. Now what happens? When suppose A has to transfer rupees 1000 to B, now it will be checked whether this 1000 amount is there in A's account or not. So this will be validated by the bank. Now bank will validate whether A is capable of sending this 1000 rupees to B or not. If capable, the bank will make the transaction to B. In that case, the bank will reduce the amount of 1000. Suppose A had an amount of rupees 8000 in his bank initially, and he has to make a transaction of 1000 rupees to B. Because 8000 is already there in the amount in the bank account, he has to make a transaction of 1000 rupees. The bank will debit 1000 rupees from here and then will credit 1000 rupees to B's account. So whatever balance B has, that amount will be added by 1000 rupees, and here a debit or a deduction of 1000 rupees will be done into A's account. Once this deduction has been done and this transaction is completed, it is recorded into the bank records. Only then A will be able to make another transaction to another person or to the same person. So, after ensuring that Bob has sufficient balance to pay for the digital money that he wants to send, he would send the money to Lisa, crediting her account in its ledger. Now it is guaranteed that Bob cannot double spend the money because that money is already transferred to B's account or Lisa's account. If every digital transaction is routed through a centralized authority like this, the problem of double spending would be solved, which normally is there when we are talking about our Indian banks or nationalized or private banks. This also provides another benefit in validating the authenticity of each coin or the digital money that it receives in the transaction. So, the duplicate money or the fake money, that is, the duplicate money is making a copy of the same money and distributing it to different people, would be easily detected and prevented from circulation. But now, we have issues with central authority as well, because the cost of creating and maintaining the centralized authority itself is very high. Because as the banks need money for their operations, they start cutting commissions on each currency transaction they do for their clients. So, if we look into our daily transactions as well, we have to pay some percentage of money to the bank, whatever NEFT or any transaction that you are doing, or maybe you are using UPI, there also you have to give certain amount of money to bank. This sometimes can become very expensive, especially in the overseas transfer of money where multiple agents or bank may be involved in the entire deal. So, it could look like a very small amount, but when we find out the consolidated amount of it, it becomes very expensive. So, all the above issues are solved by the introduction of the digital currency that is called the Bitcoin. So, now let us understand what Bitcoin is. Earlier, the banks maintained a ledger recording each transaction. This ledger is privately held and maintained by the bank, as we were just discussing in the previous slides, that bank is a centralized authority which is maintaining all the transactions or keeping a record of all the transactions that a person is doing in his or her while transferring the data while transferring money from one account to another. Satoshi proposed that there was a person, Satoshi, who proposed that let this ledger be public and maintained by the community. The moment you make such a ledger public, several considerations would come to your mind. So, this ledger has to be tamper proof, that is, nobody can modify its entries whatsoever the reason is. As each entry in the ledger is publicly visible, we will have to figure out how to maintain anonymity, that no one can make a change or there is no duplicacy of the data, because we do not like everybody in the world to know that I paid some amount of money from one person to another. Also, because there is a single ledger that is keeping a track of each and every transaction that is going on in the world. So, the size of ledger would be again a great concern, because now these transactions are divided into different banks. The transaction that you are doing by one bank will not be taken care of by another bank. But if you are doing it centralized, that everything is stored at one place, in that case the size of ledger would increase. So providing a solution to these problems was not a trivial, but that is where the blockchain came into existence. Now what we think is, what Bitcoin is or what a blockchain is. Bitcoin is not equal to blockchain. Blockchain is but blockchain is a technology that is behind Bitcoin. So Bitcoin is a digital token and blockchain is the ledger that keeps a track of the person who is owning those tokens, those Bitcoins or the digital tokens. So you can't have the Bitcoin without a blockchain, but you can have a blockchain without a Bitcoin. Now what are the different types of blockchains? The first one is the public blockchain, where a public blockchain is open to anyone who wants to participate. Anyone can join the network, validate the transactions and create new blocks. What are the characteristics? It is decentralized because a large number of nodes are distributed globally. It is accessible to everyone because anyone can participate and transactions are visible to all the participants. Some examples are Bitcoin and Ethereum. The other blockchain that we have is the private blockchain, which is restricted and usually used within a single organization. It is operated by a single entity that share the control, or we have a group of entities who share the control among themselves. So the characteristics, they have restricted access because it is a private blockchain and it is limited to certain amount of participants. So they have to be permitted by the governing entities. Because the size is smaller, so it is often faster as compared to the public blockchains. They have faster transaction processing times as compared to the public one. Examples are Hyperledger Fabrics, R3 Corda. Then we have federated or hybrid blockchains, where these are semi-decentralized. They are operated by a group of organizations rather than a single entity. Because they are operated by a group of organizations, therefore it is partially decentralized, while they have defined set of participants. It is not open to public, but it is open to limited participants. They have the controlled access, where access to blockchain is limited to consortium members, but it is not fully open to public. For example, IBM blockchain platform, Quorum, etc. Now the components of blockchain, the first one is the block. It is a collection of data that represent the set of transactions, which could include the information about the financial transaction, contracts or other type of data. They contain a unique identifier called a hash. Then we have a chain, where blocks are linked together in a specific order to form a chain. Nodes, these are the individual computers or the devices that participate in a blockchain network. Decentralized network. Unlike traditional systems with central authority, a blockchain operates on a decentralized network where no single entity has a control over the entire blockchain. So there we have consensus mechanism, where it is a protocol or a set of rules that nodes follow to agree on a state of blockchain. We have a hash function, which is a mathematical algorithm that converts the input data into fixed size string of characters, which is a hash. So this is how it works. We have a set of rules to carry out the blockchain operations. At node level, we have the server computer and the users. Transaction is the smallest building block, which is being done by two people or by a person. Block is a data structure which is used for having these transactions, and miners are the specific nodes which perform the block verification process. So how blockchain works? It operates through a consensus mechanism where the nodes collectively validate the transactions. This process is known as mining, and it ensures the integrity of the entire system. The reduction of fraud in blockchain transaction is because of this decentralized nature. So this is how it works. Suppose A wants to send money to B. So this transaction is represented online as a block. This block is broadcasted to every part of the network. Now when every part of the network approves this transaction, then the block is added into the already existing blockchain, and then the transaction is completed. So the advantage is, it is immutable in nature, it is decentralized, and it is secured because we cannot make changes to any place in the blockchain. The limitations, it is scalability, because we have a single blockchain and the size is a major issue. Energy consumption. Here the proof of work consensus mechanism is used in some of the blockchains like Bitcoin, which requires significant computation power, leading to high energy consumption. Again, the regulatory uncertainties, because we have different bodies, regulatory bodies, who are still figuring out how to handle the blockchain and cryptocurrencies. The applications, the finance, the healthcare, like in finance, smart contracts in finance automate complex agreements, streamline processes like loan approval, insurance claim, trade settlements. In healthcare, it offers a secure and interoperable platform for managing healthcare data. Supply chain management, where the supply chain processes involve numerous stakeholders and transactions. Blockchain enhances traceability by recording every step of the product's journey from manufacturing to delivery. So that's all for today. Thank you.